So DevOps gave us CI/CD. DataOps gives us data we can actually trust. And here's how to build it. Hi everyone, I'm Alex Noonan. I'm a developer advocate at Dagster Labs. And today we're going to be talking all about DataOps. DataOps is the practice of bringing DevOps principles, automation, monitoring, reliability, and collaboration to your data platform. If DevOps is about shipping code reliably, DataOps is about shipping data reliably. And here's the thing. Most data teams are doing pieces of this already. You've got schedules, you've got tests, maybe you have some alerting involved, but DataOps is about bringing all of these together into a cohesive system where you have visibility into what's happening and control over how it behaves. DataOps comes down to three basic principles. Reliability, can your pipelines recover from failure gracefully? Quality, is the data that lands correct? And visibility. Can you and your stakeholders see what's going on without digging through a bunch of logs? And Dagster gives you tools to do all three, and I'm going to walk you through them. Now let's start with reliability. The reality is that pipelines will fail. APIs time out, databases go down, and rate limits get hit. And it's not a question of if your pipelines are going to fail, it's what happens when they do. In your Dagster YAML file, you can configure automatic retries at the instance level. So any run that fails will automatically get picked up and rerun again, up to the number of times you set. So there's no manual intervention and things just work. And what's great about this is it covers so many of those transient failures that can be solved just by running the pipeline again. Also in that Dagster YAML file, you can manage concurrency. Maybe you have a Redshift cluster that can only handle so many concurrent connections. And with tag concurrency limits, you can say only 4 runs can hit Redshift at a time. And this prevents you from accidentally overloading your own warehouse. And here's a scenario every team will hit eventually once they hit a certain level of scale. And it's Monday morning, and you kicked off a big backfill over the weekend. And the backfill is still processing. But now your production jobs are queued behind it, and your stakeholders are waiting for the fresh data, but your backfill is gumming up the queue. Dagster processes runs first in, first out by default, but you can override that with the Dagster priority tag. So your critical production workloads can run first with a higher number, and you can deprioritize your backfills with a negative number. It's that easy. And when you combine priority and tag concurrency limits, you really have fine-grained control of how your runs are processed. So production jobs will always run first, backfills will only take a certain number of slots, and you won't have this situation where a big backfill gums up your entire data platform. Another reliability problem that is often overlooked is zombie runs. So runs that start and never complete or finish. And without timeouts, that run just consumes resources and blocks your queue until you manually intervene, which isn't very effective. If you enable run monitoring, Dagster will automatically detect and kill runs that exceed their maximum runtime. You can set it globally in Dagster YAML, and here I've set a 2-hour limit for run jobs, so any run that goes over this maximum time will be marked as failed, and this is a small automation that'll help with that zombie run problem. And you can override that global limit at the per job level with the Dagster maximum runtime tag. Maybe your nightly warehouse refresh takes 4 hours, but your API ingestion job should only take about 10 minutes. So you can set the right limit based on your jobs. And Dagster Insights really helps with drilling down and figuring out what the 99th percentile is for runtime. So you can really get really tight with your configuration. Dagster can even detect crashed run workers and automatically resume them. So say a K8's pod gets evicted mid-run, the monitoring daemon can spin up a new worker and pick up right where it left off. Backfills is another instance where reliability really matters. And when you need to process 100 days of data, Dagster gives you 3 strategies. You can do 1 run per partition, so maximum fault isolation. If day 47 fails, only day 47 will retry. You can do batched runs, so you can group partitions together. So 100 days becomes 10 runs of 10. You reduce your overhead by 90%. And if you're on Dagster Plus, you reduce your credit usage as well. Or you can do a single run, which is great for a Spark or warehouse intensive processing where you want to minimize the overhead. And here you can manage the backfill policy on your asset. And 1 line of code change you can go from 100 runs down to 10. And that's what makes Dagster such a great tool for data ops, is you can make the reliable path the easy path. Now, reliability for your pipelines running is important, but the running isn't enough. The data also has to be right. And this is where asset checks come into play. Now, asset checks are a data quality test that are tied directly to your assets. They run after materializations and they show up right in the UI next to the asset that they're checking. And what I love about this is how simple it is. You're just writing a Python function that returns a pass-fail. No new DSL, no separate testing framework, just Python. And if you're more comfortable with DBT tests, those will come up in your Dagster project as asset checks. And here's where it gets really powerful for a data ops perspective. You can set different severity levels for your asset checks. So a warrant severity is not blocking, it is just something that you want to note, and downstream assets can still run. Whereas an error severity is a blocking asset check result. So any downstream assets will not materialize. And this is useful for a few reasons. One, it's easy to drill down and figure out what the issue was in a pipeline failure. So you don't need to dig through a bunch of logs. You can clearly see this is the asset where everything failed. And two, you don't have bad data being propagated through your system, which is critical for establishing data platforms trust. Because it's a lot easier to say that the data is stale than that is incorrect. And when you have a lot of checks, which you will, you can use multi-asset checked or a factory pattern to define them at scale. All right, so your pipelines are now more reliable. You have a data quality process in place, but it kind of doesn't really matter if you and your team can't see this in an intuitive way. And that's where Dagster Plus really shines as a data ops tool. So I'm going to take you through a demo of save selections. All right, so here I am inside of my Dagster Plus environment, and I got around like 100 or so assets. So it's a real data platform with multiple code locations and a few team members. And honestly, trying to comprehend everything at once can be a challenge. And oftentimes when you're working within a data platform, your issues are often very focused around specific pipelines or use cases. So one of the things you can do in Dagster Plus is create a saved selection that is a lot more focused, and we have a pretty robust selection syntax. And so I want to look at the orders pipeline. So I'm going to focus on the raw data / orders. I want all the downstream assets that flow from that. And then I want to exclude the assets in the marketing group. And what's nice is you don't have to remember the syntax. You have all these helpers in here. So I'm going to filter that. And then we have 18 assets here, which is a lot more manageable than the 50 we started with. So I'm going to save this selection here. We'll call it raw. We'll call it the orders pipeline. And then I'm going to assign it an icon. Yeah, we'll use Instagram. Cool. And then now when I go to the lineage, it is just focused on this. So that's a lot easier to grasp. And additionally, we can go to insights, and all the insights data is sliced on that same selection, which if you're like a pipeline owner for a specific pipeline or another group, it's a lot easier to manage that way. And additionally, you can set alert policies for this selection as well. So we'll use our custom selection, and then you can do specific events, table schema changes, health status change. I'll keep it simple, so I'll just have it for degraded. And then I can set it as a Slack, and then and what's cool about this is we can pin this to the home page. So anytime we log in, it'll be one of the first asset groups that pop up. So here we are with the orders pipeline right here. It'll take us back to this page so we can then drill down or do whatever we need to do. So that's data ops with Dagster. In recap, we covered reliability through retries, run priority, timeouts, concurrency controls, and smart backfill strategies. We also discussed quality through data asset checks and severity levels to catch bad data before it spreads, and visibility through saved selections in the Dagster Plus UI so everybody can get a view that is tailored to them. Data ops isn't a one-time setup, it's more of a practice. And Dagster gives you the building blocks you need where you can adopt it incrementally as you run into problems scaling your data platform. And if you want to dive deeper, I'll leave the links to the docs in the description. And if you got any questions, our Slack community is the place to go. See you in the next one.